And just try understanding this derivation, what it means. There are different forms of it. You can choose which one to follow. The basic derivation is simple, but there's something that you can expect almost every exam. They ask this derivation. The derivation of the Coulomb's law and vector form. So what we have seen now, till now, was just the concept, the basic concept of the Coulomb's law and the magnitude of this force. But imagine, okay, I'll first do the simple derivation, then I'll do the vector one. Or you can have the two one like this also. Let us say these are the two charges, Q1 and Q2. Now, if these are the two charges, for sure, I need to show their position in terms of a Cartesian coordinate, right? Along x-axis, y-axis. I need to show their position. Yes. So I'm saying that, let us say the first one is located over here at a position vector R1 vector. And the second one is located somewhere here. The position vector is R2 vector. Are you all understanding this? No problem. The distance between them is R. So this vector, as you know from the triangle law of vector addition itself, this is going to be nothing but R2 vector minus R1 vector. Yes, Rishi. Yes, Rishi.
I just got logged out. Can you add me back?
Yes. 1 second. Can you just try entering the room? I
Yes,
think
I'm trying. It's saying host is joined, but let them know you're here.
Amartya, you are the host. Can you add Rishi again?
Yes, sir. I added.
Okay. Okay, Rishi, are you there?
Yes, sir.
Okay. Again. I'll start again. See, everyone, I want all of you to pay attention to this derivation. Suppose we have two charges, Q1. One charge is Q1. Another charge is Q2. It's placed in some random position in space. But if it is placed at some location, we have to show where it is, no? So that for that we draw a coordinate. So this is my regular x-axis. This is my regular y-axis. No problem. Now I draw the position vector of the first charge. Let's call this as R1 vector. Position vector of the first charge. And let the position vector of the second charge be equal to R2 vector. All of you are understanding till here? No problem. The distance between them is this. And the value will be R2 vector minus R1 vector. Can I say this? The direction is of course in this direction. So R2 vector minus R1 vector. Section is in this direction. Can I call this as R2 1 vector, starting from 2 going towards, or starting from 1 going towards 2? Can I call it like this? See, R2 minus R1. Understood this, everyone? Towards 2 from 1. That's how you should read. R vector is towards 2 from 1. Got it? Let us say these charges are positive. Both of these charges are positive. One thing we know, that Q1 is going to repel Q2 in this direction. And Q2 will repel Q1 in this direction. Yes? Follow each and every step, okay? Anyone has got any problem in the position vector? First, tell me that. So I've got two charges, Q1, Q2. I'm saying their position vectors are R1 vector and R2 vector respectively. So when I join them to check what is my displacement vector between the two charges, it is obviously going to be R2 minus R1. Yes? R2 minus R1. Correct? And you can see that R1 has to be like this, R2 minus R1 has to be like this, then only the R2 will be the resultant, no? Yes, basic vectors, which means R2 minus R1 has a direction in this direction, correct? Yes, everyone is getting this? Now I'm saying let's call this R2 minus R1 as R21 vector going towards to starting from 1. No problem. Which has got a magnitude equal to R2 minus R1, which is equal to R. And direction. So R21 vector can be written as magnitude of R and R21 cap, which is this direction. Did everyone follow this? Rishi, Amartya, Elvin,
Yes, sir.
Lakshita.
Yes, sir.
Yes, sir.
Followed it? Know what I'm saying? I'm saying R2 minus R1 is a vector. R2 minus R1 is this vector. I'm calling this R2 minus R1 vector as R21 vector going towards to starting from 1. No problem. Going towards. So whatever is just sticking to the tail, no, is where it is going. And what is after that is from where it is going. I'm calling this vector as R vector magnitude of R times R21 cap, which is this direction. Any issues, anyone? No problem. No problem. Now, let's talk about the force that one applies on another. This charge Q1 is going to apply a force on Q2 in this direction. Yes. Can I call this as force on 2 because of 1? Can I call it like force on 2 because of 1? Yes. Things are making sense, guys.
Yes,
Can I say
sir.
that?
Yes, sir.
Both of them are like charges. Both of them are like charges. Either positive, both of them are positive or negative. We can do it for unlike charges also. I'm just doing it for one. So what I'm saying is Q1 is trying to repel Q2. So Q1 wants Q2 to go away from itself. So it will apply a force in this direction. Yes or no? We are calling that as F21, force on 2 because of 1. That's how you read it. Force on 2 in terms of vector. That's how you read it, okay? Force on 2 because of 1. Any problem in this, guys? No problem, no? What will be this vector equal to? Force on 2 because of 1 can be written as the magnitude of the force first. Magnitude we know already. K, Q1, Q2 upon R square. Yes. Correct. What about the direction? Direction is R21 cap, right? Any problem?
No problem.
Any problem? Now
Mm.
from here, I can write R21 vector by magnitude. This is nothing but magnitude of R is nothing but R21 cap. Can I write it like this? Can I write it like this, guys? Yes.
Yes, sir.
Okay. Which means I can also write this as F21 force is equal to K Q1 Q2 upon R square times, instead of R cap, can I write it as R21 vector divided by R? Following all this step? Following this, guys?
Yes, sir. Yes, sir.
Can I also write F21 vector is equal to K Q1 Q2 upon R cube times R21 vector? Just multiplied this R over here.
Yes, sir.
This is called as vector form of Coulomb's law. This is called as what? Vector form of Coulomb's law. Now in different books, you can get R in a different way. Some people will write R. This we have taken as R, no? Some will write R as R2 minus R1 ka mod ka whole cube. How does it make a difference? Did you understand this? The same expression. Did you understand how they are
Yes.
going to write? So
Yes,
in
sir.
different books, different places, you will see different notations, but you need to understand how you got it there. Okay, so some people might write this as F21 vector is equal to K Q1 Q2 upon, instead of R, can I write R2 vector minus R1 vector magnitude ka whole cube? Can I write it like this? And R21 vector can also be written as R2 vector minus R1 vector. Can I write like this also? It's one and the same thing. So even if you get this expression is also correct. This expression is also correct. This expression is also correct. Both of them are correct. Depends how they have taught you. Whichever way they teach you in school, you just do it in that way. It's just that assuming R2 minus R1 vector is equal to R vector, magnitude is equal to R. No problem.
Yes, sir. Just a second.
I have to copy this in the notebook, right, for this derivation.
Which one? Sorry, did somebody ask something?
Yeah, so we have to copy this derivation in the notebooks, right? You told.
Yes, you need to. Yes, definitely. You have to copy this. Just try doing it yourself. Remember the steps. Shall I do it again?
Yes, sir.
Shall I do it from the beginning? One more time.
Yes, sir.
How we started off? We told that there are two charges, Q1 and Q2. We want to find what is the force that exists between the two. So we told, okay, let's say the position vector of the first charge is R1 vector. We said, let's say the position vector of the second charge is R2 vector. We know the separation between them is going to be R2 vector minus R1 vector. Yes, no problem. Then we told, okay, R2 vector minus R1 vector. If I check its magnitude, let's take this magnitude as R vector, R, or let the value of this is equal to R. R2 vector minus R1 vector, let's call this as equal to a vector R, where R vector has magnitude of R and direction going towards 2 coming from 1. This direction, which is the direction of R2 minus R1 vector. Any problem? Any problem till here?
No, sir.
Then what we told, okay, so how is the force being applicable here? We told Q1 is trying to repel this. So Q1 will try to push Q2 in this direction. Let's call this force as force on 2 because of 1 in form of vector. So we have written force on 2 because of 1 in terms of vector is equal to, in terms of magnitude, it is K Q1 Q2 upon R square. And what is the direction? Just now we have seen the direction is supposed to be R cap towards 2 coming from 1. Yes. Any problem, anyone?
No, sir.
Sir, I can't understand the last step. Force on
Force on 2 because of charge 1 will be repulsion. They are like charges. No, we are doing it for like, okay? So Q1 will try to repel.
Yeah, then how do we get K into Q1, Q2 by R square?
This is the magnitude of the force, no? This is the magnitude of the force by Coulomb's law.
Yes, sir,
So
okay.
Coulomb,
Okay.
so Coulomb's law gives us the magnitude of the force. It tells us the magnitude of a force is product of the two charges directly proportional to product of the two charges inversely proportional to square of the distance between them. And if nothing is given, we'll always assume that there is air. So K, which is equal to 1 by 4 pi epsilon. Got it?
Okay, sir.
So magnitude wise we have written, but we have to write a force is a vector quantity. So we need to write it in vector form, no?
Okay.
Got it? Okay, Pranav, you were asking, right?
Yes, sir.
So we are showing that the direction is this direction. Basically, this is what we mean. We mean
Yes,
to
sir.
say that from 2 towards 1 means that this force is going towards 2 from 1. So this is the direction. Going towards 2 from 1, which means away from 2, away from 1, basically. Repulsive force. Any problem now? Anyone else has got any issues with this?
No, sir.
No, sir.
So
Rishi, clear?
Yes, sir.
Okay. Now, what we told is that we can also write F21 vector is equal to K Q1 Q2 upon R square. This remains as magnitude. We are not touching it. This comes from the Coulomb's law. R21 vector can be written as what? From here, R21 cap can be written as R vector divided by magnitude of R vector. Can I say this? This is nothing but magnitude of R vector, yes. Any vector can be written in terms of magnitude and its unit direction. Yes or no? Guys, you all are clear with vectors, no?
Yes, sir.
Pranav, Rishi, you guys are clear with vectors, no? Basic idea of vectors you all have, right? Huh?
Yes, sir.
Anything of the 11th standard, if you don't know, don't hesitate. Ask me, we can have a special class only on vectors if you want. We'll revise.
Can we have like I'm just a little good on vectors.
Sorry, Pranav, your sound
Yeah,
is not
sir.
clear.
Yeah, sir. So yeah, I'm not that good on vectors, sir. So a little.
Okay, who all wants a class on vectors? Lakshita, Amartya, Alvin, Rishi.
Sir, if
Do
you're
you
having
guys-
one, I can join.
Oh, if we are having, you'll join. Amartya,
sir, same, sir.
Alvin,
Sir, I'm clear with vectors, but I'll just join.
okay, Rishi.
Yes, sir. I'll join the class. The vectors.
Okay, so shall we have one small class tomorrow? One class, just for basics of vectors. Cool?
Yes, sir.
Yes, sir.
Okay.
Okay.
Okay. Because see, vectors you'll need definitely in all, like going forward, you'll definitely need vectors. Okay. So we can have one class for vectors, don't worry. But see, vector basically means that anything which has got magnitude and direction. And over here, you are talking about magnitude, and this is the direction. All right. Okay. So if can I write unit vector as R vector divided by magnitude of R vector? There's nothing but R, so it can be written as K Q1 Q2 upon R cube times R cap. R vector. From where to where? From 2 to 1. This is F21. Understood this now? This derivation is clear. Similarly, if somebody tells me to do it for force on 1 because of 2, we know the force will be in this direction. Let me do it with another color. So 2 will repel 1 in this direction, yes or no? 2 is going to repel 1 in this direction, correct? What is this direction? Can I say this direction as minus R21 cap? See, R21 cap was this. So opposite direction will be minus R21 cap, no? Are you understanding this, everyone? This direction is R21. So what is this direction? Minus R21 cap. Can I say that? Yes, Elvin, Amartya, Rishi, Lakshita. Clear, no?
Yes, sir.
Yes, sir.
So how do we write force on one because of two? Force on one because of two will be repulsion in this direction. Magnitude is going to be same Q1, Q2 upon R square. And this will be minus R21 cap. Yes. Clear, guys? Again, I can take the minus sign over here. I can write K Q1 Q2 upon R cube times R21 vector. Yes, can I say this? Can I also say force on 2 because of 1 is equal to negative of force on 1 because of 2? So they are action reaction pairs. Did you understand? They ask you to prove it. Did you get it, guys? Tell me, is this derivation clear?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
You get all these derivations in your notes also, so don't worry. Okay. All right. So this is one very, very important derivation. Now I have a homework for you. In the same way, can you do it for unlike charges? On your own. Can you try it on your own for unlike charges? Any problem in the vector form of Coulomb's law? Anyone?
No, sir.
Alvin, Amartya, Rishi, Pranav,
No, sir.
No, sir.
understood? No, all the steps? Yes.
Yes, sir.
Okay. Can I clear this?
Yes, sir.
Next is called as principle of superposition. Principle of superposition. What does it tell you? Principle of superposition tells us that if there are many charges like Q1, Q2, Q3, and there is a charge Q0, the force on Q0 because of Q1, let us say, is in this direction. The force on Q2, Q1 because of Q2 is, let us say, in this direction. On this one, it's this direction. Let us say this is F2, this is F1, this is F3. The net force on Q0, F net, will always be a vector sum of F1 vector plus F2 vector plus F3 vector. Did you understand? What did it say? If there is many charges, because now we have only done it for two charge system, no? Now what we have learned is only for two charge system, only when there are two charges, then the force is equal to K Q1 Q2 upon R square. But if there are more than two charges, for every charge we'll find out the value. So F1 will be K Q1 Q0 upon R1 ka square. F2 will be K Q1 or Q2 Q0 R2 ka square. Did you understand? F3 will be K Q3 Q0 on R3 ka square. And then you need to add them vectorially, not just the normal addition, but the vector addition. Got it?
Yes, sir.
Okay, let me ask you some questions of previous year exam. The question that has come in 2014 board exam. I want all of you to answer this orally. So listen to the
Sir,
question.
just a second. I'll just copy this. Just a second.
Uh-huh. Okay, now I want if you guys can switch on the camera, please.
Sir, I'm in the car right now, so it'll be a bit difficult
Oh.
to.
Oh, no problem, Rishi. No problem. You can just answer.
Yes, sir.
All right, ready? The question says two equal balls having equal positive charges Q Coulomb are suspended by two equal insulating strings of equal length. Got it? So there are two equal balls, two balls suspended by string at some length. The charges are same, Q and Q. The question is, what would be the effect on the force when a plastic sheet is inserted between the two, having a dielectric constant K? So initially when they were in air, the force was F. What will be the effect? What will be the new force if there is a plastic sheet which is inserted? The dielectric constant of the sheet is K. Tell me the new force.
1/4 pi E.
Just in terms of F. Will it be more than F or less than F?
More than F.
More than F, sure.
Sir, in air, F will be minimum value, right?
No, in air it will be maximum value because air permits everything. Are you getting it? In air there is no blockage, no.
Oh, okay, yes, sir. So it'll be less than F.
By how much? By K.
By
Did
K.
you understand? F in the medium is equal to F by K. So when you place, did you understand how they asked this concept? Just now we explained, no? Force will always get reduced if you place a dielectric medium of dielectric constant K. By what factor? By the same factor as that of its relative permittivity or dielectric constant. Got this question, everyone? Everyone is clear with this question?
Yes, sir.
Yes, sir.
Okay. Mm, 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 mm. Okay, next question. 2-point charges having equal charge. This was asked in 2011, 2013. Question is 2-point charges having equal charges separated by 1 meter distance experiences a force of 8 Newton. What will be the force experienced by them if they are held in water at the same distance? Dielectric constant of water is 80. Understood what they have asked? They're saying that there are two charges kept at 1 meter distance in air. All right, and the force is 8 newtons in air. What would be the force if they're kept in water? The dielectric constant of water is 80. What will be the force in water? Tell me.
Yeah, so it will work it out in 10. Yeah.
Yeah. Work it out. You don't have to write it also. This is such a simple question. In air, the force is 8 Newton. In water, the force will be, if the dielectric constant is 80, is how much?
So will it be 0.1 if you
Yes.
divide it?
Yes. Yes, absolutely.
Yes, sir,
Force in
0.
water. Yes. Correct. Force in water is going to be force in air divided by K. How is K defined? K is equal to force in air divided by force in the medium. Correct, no? That was the ratio by what value the force decreases. Correct, no? Yes. So force in any other medium is equal to force in air divided by K. So what we have got, 8 divided by 80. This gives you 1 by 10. That is 0.1. Got it? So you see, what is the effect of water? The water has reduced the force by such a fraction. It has made it 80 times lesser. So unlike universal gravitational constant, wherein between every entity, the force used to remain the same, this is not the case here, right? It is dependent on the medium. So in different medium, the forces are going to be different. Clear? Clear with this, everyone?
Yes, sir.
All right. Other questions are also there. Mhm. Okay, there is one question number 27. Okay, the question is the sum of 2-point charges. The sum of 2-point charges. This is the question. 2009, 2013, 2011. 3 times they have asked. The sum of 2-point charges is 7 Coulomb. Sum of 2-point charges is how much? 7 microcoulomb. All right. They repel each other with a force of 1 Newton, which means both of them are similar charge. They repel each other with a force of 1 Newton. When kept 30 centimeter apart, when R is equal to 30 centimeter. All right. Calculate the value of each charge. What is the value of each charge? Where the sum, that is Q1 plus Q2, is equal to 7. Did you understand? And the value of 1 by 4 pi epsilon naught, nothing is mentioned. You can directly take this value, is equal to 9 into 10 to the power 9. So how we will find? Let's say one charge is equal to X. So other charge is going to be equal to what? 7 minus X. I know force is equal to 1 Newton, which is equal to K, which is, okay, let me first write the formula. See how you solve this. So the question was this, that there are two charges. Let's say one charge is X, the other charge is certainly going to be 7 minus X. All of you understood this point? Because their sum is given as 7, correct? Then I know the force will be given by the magnitude K Q1 Q2 upon R square, where R is also given 30 centimeter. We have to find Q1 and Q2, correct? The value of K is also equal to 1 by 4 pi epsilon naught, which is 9 into 10 to the power 9. Now, the force is also given equal to 1 Newton. So you know this, you know this, you know this. All you have to find is Q1 and Q2. So Q1, I take it as X. Q2 becomes equal to 7 minus X. Are you all understanding this, everyone? So now what we'll put we'll substitute the value. 1 is equal to everything in SI unit. 9 into 10 to the power 9 times Q1, which is X into 10 to the power minus 6 microfarad, no? Times 7 minus X into 10 to the power minus 6 divided by 30 centimeter, which is 0.3 meters per whole square. Clear with this? Yes? Correct, no? See, what do you get? 10 to the power minus 6 can be taken as common. It will be how much? 10 to the power 9 into 10 to the power 9, 10 to the power minus 2. How much will this be? 10 to the power minus 6. 10 to the power minus 6 will be 10 to the power minus 12, right? And this is 10 to the power minus 9. So this is equal to, I can take this 0.3 square, which is nothing but 0.3 into 0.3, correct? 0.9, and this is going to be equal to 9 into 10 to the power of minus 3, correct? This is 10 to the power 6, 10 to the power 6. 6 plus 6, 12. Plus